Hey guys, welcome back to my channel Cloud Tech Services. In today's video, we are going to understand Microsoft Endpoint Manager Suite in a very simple way. If you are an IT student, beginner IT professional, desktop support engineer, system admin, or someone who wants to move from traditional device management to modern cloud based management, then this video is for you. By the end of this video, you will understand important topics like Microsoft Configuration Manager or SCCM, co-management, cloud attach, Windows Autopilot, Endpoint Analytics, Windows Autopatch, and Windows 365. So, stay till the end because these are very important topics for modern IT administration and Microsoft Cloud device management. And before we start, please subscribe to Cloud Tech Services and press the bell icon so you don't miss upcoming videos on Microsoft Intune, Azure, Microsoft 365, and cloud technologies. Today, we are discussing the components of Endpoint Manager Suite. In many organizations, IT teams still use on premise tools to manage devices. One of the major tools used for this is Microsoft Configuration Manager, also known as Config Manager or SCCM. Configuration Manager is mainly used to manage Windows devices inside the company network. With Config Manager, admins can deploy applications, install updates, manage operating system deployment, and monitor devices. But today, due to the changing workplace culture and mainly post COVID 19, organizations have shifted towards remote work culture, providing users with working from home facility. In such a scenario, it is not necessary that the devices are always connected to the company network physically. Thus, many organizations are moving to the cloud to provide their employees the provisions to work from anywhere around the world. This is where Microsoft Intune and modern endpoint management becomes very useful. Microsoft Intune is a cloud based service that helps admins manage devices, apps, security policies, compliance, and perform remote actions from anywhere around the world. Many companies do not move everything to Intune in one day. Microsoft Intune has the facility to be integrated with on premise services to ease out the cloud adoption program of Microsoft and help organizations slowly transition into cloud. For organizations which already have Configuration Manager running in their environment for device management, Microsoft provides options like co management and cloud attach with Configuration Manager to integrate the on premise service with Intune to leverage the Intune capabilities in their environment without the complete transition to cloud. Let's understand them one by one. First, let's talk about Cloud Attach. Cloud Attach helps connect our existing configuration manager environment with Intune. It mainly has two steps. First is the tenant attach, and the second is co management. With tenant attach, admins can see and manage configuration manager devices from the Intune Admin Center. This gives centralized visibility of devices, device health, and actions inside the cloud portal. The cloud attach also allows admins to perform remote actions such as restart, remote control, or factory reset from Intune. It also supports conditional access based on device compliance. In simple words, Cloud Attach helps bring your on premise configuration manager environment closer to the cloud. The second component of Cloud Attach is called as co-management. Co-management allows organizations to manage Windows devices using both Configuration Manager and Microsoft Intune as is visible in the image. This means the company can continue using Configuration Manager for specific workloads and start using Intune for cloud-based management. For example, an organization may use Configuration Manager for application deployment and use Intune for compliance policies or conditional access policies. This is very helpful because companies do not need to remove their existing setup immediately from the on premises to Intune. They can slowly move workloads to Intune step by step. Co-management is mainly useful for hybrid environments, especially where devices are hybrid Azure AD joined, or we can say hybrid Microsoft Entra ID joined. Another component which works hand in hand with Intune is the endpoint family services. There are four services as part of the endpoint family services, namely Windows Autopilot, Endpoint Analytics, Windows Autopatch, and Windows 365. Let's check each service one by one. Windows Autopilot. The Windows Autopilot is one of the most important features in Microsoft device deployment. Previously, whenever a new laptop was given to a user, IT admins had to manually install Windows operating system, install drivers, install applications, join the device to the domain, and configure policies on the devices. This process of imaging the device took a lot of time for the IT admins. But with Windows Autopilot, the device setup process becomes much easier. Windows Autopilot helps enroll devices into Intune automatically. This image right here shows the full life cycle of a business device, such as laptop or a desktop, deployed using Autopilot. There are 7 major phases through which a business device passes from purchase through deployment, daily use, repair, and eventual retirement. The first phase is to purchase the device. The customer buys the device from the vendor. The vendor can either be a manufacturer or an OEM reseller. This starts the device lifecycle. The vendor prepares the device and ships the device to either the customer or to the employee. During this process, the vendor prepares the device and ships the device to either the customer or the employee. During this process, the vendor exports the hardware ID of the device needed for Autopilot and shares it with the purchasing company if the device is being directly shipped to the employee. If the device is not directly shipped to the user, it arrives to the organization where the device is made ready for the user. The hardware ID is exported from the device and is added to the Autopilot profile on Intune. As part of the deployment step, the Intune environment preparation is also done. It is a one-time configuration for preparing the Autopilot profile, policies, and applications and deploying them to the correct device groups. This can be done in advance even before the devices are received. Don't worry, we would have a dedicated video on Windows Autopilot, its configuration, and how that works. Once the device is all ready, it is then sent to the employees. The device setup is a complete self service experience on the user end. The autopilot enables the user to complete the setup themselves when the users need to connect the device to the internet and sign in to the work account. As soon as the device is connected to the internet and the user signs in using his work account, the device automatically picks up the autopilot profile deployed on that device and would start the device deployment and registration process by itself. The primary aim of the autopilot service is to reduce IT effort and let the employees become productive quickly. After the setup is done, the device is now fully configured and secured. Now, this device is being managed by Intune and Windows Security, which ensures that the device is managed by the organization, protected under the security policies, configured with the required software and application, and is ready to access the company resources. With this, the device enters a state of normal operating period. During the steady state, IT continues to monitor and manage the device and keeps it current and secure by installing latest updates and patches, monitoring compliance, deploying applications, responding to security issues, changing configurations, and supporting users as per their need. The steady state is considered as the longest state of the device in the entire device life cycle. If the device develops a problem, it can either be repaired, reset, or reconfigured, which is shown in the break fix or reset stage. Some typical break fix actions may include troubleshooting hardware and software issues, reinstalling the operating system, performing a factory reset, reapplying the company policies, and replacing a defective device. Additionally, if a device is stolen, Intune gives the capability to wipe the organization data from that device. The curved arrow in the image shows that once the device is ready, it returns to its steady state, ready for business, and can be reused. Eventually, the device may become no longer suitable for use because it is old, unsupported, damaged, or too costly to maintain. At this stage, Intune provides a facility to remove the company data and retire the device from device management by recycling it, returning it to the vendor, or replacing it with a new device. This is the closed loop of the device lifecycle management model, which Intune manages using the Autopilot service. Autopilot is very useful for local as well as remote employees. For example, if a company hires a new employee in another city, IT team can directly ship the laptop to that employee. The employee opens the laptop, connects to Wi Fi, signs in, and the device gets configured automatically. Now that we have looked into the Windows Autopilot device lifecycle, let's see some of the key features of Autopilot. Autopilot simplifies device enrollment in Intune. The policies and profiles that are configured on Intune beforehand are pulled into the device during the Autopilot setup. When the employee connects the device to internet and signs in to his device using his work account, the device automatically pulls the Autopilot profile and starts the deployment, installation, and configuration all by itself. It also helps users configure the device in only a few steps. The user only needs to connect the device to the internet and sign in to the device, and the autopilot takes care of the rest of the deployment. It automatically joins the device to Microsoft Entra ID. The Autopilot profile joins the device to Microsoft Entra ID, and no specific action is required either from the admin or from the user to perform this specific task. It auto enrolls the device into MDM services like Microsoft Intune. Autopilot can also restrict local admin rights of the user logging into the device. There are provisions that the first user that logs into the device during the process of Autopilot is not given local administrative rights and instead made a standard user. Autopilot can also assign devices to specific configuration groups, and it can show customized company branding during the out of box experience. Now that we have seen the features of Autopilot, let's see some of the advantages of Autopilot. Now, Windows Autopilot comes with its own set of advantages. The first advantage is that it reduces the IT administrator time required to deploy, manage, and retire the devices. The admins do not need to manually prepare every device. It is very useful when thousands of devices needs to be prepared and configured in a very short period of time. It also reduces infrastructure requirements. Traditional imaging servers and complex deployment infrastructure might not be required in many cases, especially if the device would only be managed by Entra ID. And the third, it improves user experience. The users get a simple process to set up and can start working faster as soon as they receive the device. With these advantages, there are a few disadvantages or limitations of Autopilot as well. Unlike Configuration Manager, the Windows Autopilot is not a full imaging solution. It can only apply configuration policies on top of the existing OEM installed Windows operating system. Using Windows Autopilot, we cannot create custom system images, which can be an issue if the organization requires a completely standardized based install. And my admins who have previously worked with operating system deployments using Configuration Manager would relate to this problem. Hardware replacement and repair issues. In traditional Autopilot version 1, the device identity is strictly tied to the hardware hash, which includes the TPM data. If the motherboard of the device is replaced, the device loses its connection to the tenant and requires a time consuming re registration and reprovisioning. Reliance on OEM bloatware. Because Autopilot transforms the factory installation, we are subjected to the OEM's preloaded software. The IT teams often have to write custom PowerShell scripts or request clean vendor images to scrub the junk, cloud, and network dependencies. The devices must be connected to the internet right out of the box and have unblocked access to Microsoft endpoints. If your Wi Fi requires a complex certificate or web based login, at the out of box experience screen, the Windows Autopilot deployment will most likely fail. Complex setup and hidden dependencies. Setting up your Microsoft 365 environment, Azure Entra groups, and Intune MDM policies requires steep upfront planning. If something breaks, troubleshooting can be difficult due to limited visibility into the background deployment process while provisioning the device using an autopilot. Enrollment status page bottlenecks. During setup, the ESP prevents user access until everything is configured. This is one of the major issues that the admins face using autopilot. When the autopilot is running, the user cannot perform any other option and they cannot log into the system. It's basically a static screen that shows the progress of the Windows autopilot provisioning. Loading the ESP with too many large applications or scripts can cause severe installation delays or timeouts. And licensing requirements. To use Autopilot, we need specific premium licenses such as Microsoft 365 Business Premium, Enterprise Mobility Plus Security, or the EMS license, or the Intune license. So, if your organization wants modern deployment, Windows Autopilot is a very important feature to learn. But it does come with some advantage and some limitations which do need to be considered while configuring the autopilot. Now let's talk about the second endpoint family service, which is the endpoint analytics. Endpoint analytics helps IT teams understand how well devices are performing in the organizations. Many a times, users complain that their laptop is slow, startup is taking too much time, or applications are not responding properly. Instead of waiting for help desk tickets, Endpoint analytics helps admins identify these issues proactively. It provides insights into device performance and user experience. It can help identify configuration problems or hardware issues that are slowing down devices. It also provides recommended actions to fix these problems. Endpoint analytics is also part of the Microsoft Adoption Score. So, in simple words, if you want to understand what the endpoint analytics does, it basically helps the IT teams answer few questions such as: are the users getting good device experience? Which devices are running slow? Which configurations are causing problems? Which devices may need an upgrade or a replacement? The endpoint analytics console looks something like what's seen in the image right here. It has the endpoint analytics score, it shows the baseline, and there are reports that can be pulled into for startup performance, proactive remediation, application reliability, and work from for anywhere. Let's now look into the advantages of endpoint analytics. Proactive issue resolution. The analytics platforms measures startup times, hardware health, and application reliability to address any sluggish performance before the employees are gravely impacted by it. By automating remediation scripts and preventing device crashes, IT teams spend less time troubleshooting individual machines, which in turn reduces the IT cost. It also enhances the employee experience by providing reliable, well performing devices, which increases worker productivity and decreases the technology related frustration. Security analytics use behavioral baselines rather than just malware signatures to spot unauthorized access, insider threats, and sophisticated attacks immediately using the endpoint analytics real time threat detection. There can also be data driven procurements depending on the telemetry of CPU, RAM, and battery health, which the endpoint analytics reports provides. It helps the IT leaders understand exactly which hardware models to perform the best, guiding future technology purchases. The endpoint analytics also has some limitations. The endpoint analytics agents may require significant CPU, memory, or disk space to continuously monitor and report the device activities. And this heavy processing can cause the systems to slow down, drain battery, or even freezing, leading to poor user experience and potential pushback from the employees. Automated profiling and behavioral analysis can mistakenly flag legitimate, safe software or administrative actions as, as anomalous threats, and these overabundance of priority alerts or inaccurate diagnostic scores can cause the IT teams or the security teams to miss a genuine threat. The endpoint data also focuses entirely on the individual user device. So it offers little to no insight into the network-wide traffic, cloud environments, or any other compromised servers that can be in place. Thus, taking advantages of such blind spots, attackers can exploit the infrastructure vulnerabilities, misconfigured cloud setups, or lateral movements between servers, and completely bypass the endpoint defenses. The setting up of the analytical solution, especially in environments which have strict proxy rules or varying network topology, can be very complex. And the agents can also conflict with other installed softwares or operating systems or even existing security tools. So there can be compatibility issues with regards to endpoint analytics agents. Along with that, the licensing, deployment, and ongoing maintenance can also become very costly. Many native tools require premium suite licenses to access full capabilities. Collecting deep telemetry data, app usage, and keystrokes can raise privacy concerns among users and may conflict with strict regional data privacy regulations, which can hence result in privacy and compliance constraints. So, these were some of the limitations of endpoint analytics. The next service that we have is called as the Windows Autopatch. Windows Autopatch is a cloud based Microsoft service that automates the update process for Windows, Microsoft 365 applications, Microsoft Edge, and Microsoft Teams. In traditional environments, admins used to spend a lot of time planning, testing, and deploying updates. They needed to make sure updates do not break the user's devices. Windows Autopatch helps by managing updates automatically using deployment rings. The service arranges devices into different deployment rings. Updates are first rolled out to smaller groups and then gradually to more devices. This helps reduce risk. If there is any issue, the Autopatch also has built in halt and rollback capabilities. But Windows Autopatch is heavily dependent upon licenses, such as Windows Enterprise E3 or higher, Windows 365 Business Premium, or Windows 365 E5, and the devices should be Microsoft Entra joined or hybrid Entra joined for being able to use the Windows Autopatch feature. Let us now look into a few advantages of Windows Autopatch. Windows Autopatch reduces the IT administrative overhead. Microsoft handles the orchestration, testing, and progressive rollouts of update. The IT staff are freed from manual scheduling and can redirect time to more strategic projects. There is minimized user disruptions. The updates are delivered sequentially in progressive deployment rings, catching bugs in early adoption groups before the widespread rollout. Windows Autopatch also has built in halt and rollback capabilities. The service continuously monitors device health and update success rates. If a patch causes widespread issues, the service automatically pauses the deployment and rolls back devices to previous configuration. Continuous security and compliance. It helps organizations reach their security goals, such as keeping more than 95% of devices on the latest quality updates. Also, it provides detailed compliance reporting via the Microsoft Intune Admin Center to ensure the admins can track system status easily. In general, the Windows Auto Patch is included at no extra cost for organizations that already have the Windows 10 or 11 Enterprise E3 E5 licenses, Microsoft 365 E3 or E5 licenses, and the Business Premium license. Windows Auto Patch also comes with few limitations. There is lack of granular control. The administrators cannot manually select specific update installation dates, times, or pilot deployments like it was with regards to SCCM. The service uses progressive, predefined rollout rings and schedules. The Windows Autopatch operates exclusively within the Windows 10, 11, Intune, and Entra ID ecosystem. It does not support Linux, Mac operating system, or the Windows Server endpoints. There are also no third-party application support available with Windows Autopatch. It only handles Microsoft products. Organizations will still need separate solutions to patch non-Microsoft applications. Limited reporting and data longevity. Intune and Autopatch have been noted in community discussions to have data retention limits, often up to 90 days, and reporting inaccuracies, making deeper long term tracking harder than the legacy tools that were available, like SCCM. Windows Autopatch restricts its scope primarily to feature updates, security quality updates, and driver updates. Non security quality updates are not deployed using Windows Autopatch. The final endpoint family service that is supported with Intune is called as the Windows 365. Windows 365 is also known as Cloud PC. It allows the users to securely access a full Windows 10 or Windows 11 desktop from the cloud through an internet connection. This means the actual Windows desktop runs in the cloud and the user can access it from different devices. For example, for example, a user can access their cloud PC from a personal laptop, office device, tablet, or supported browser. The user gets their desktop, apps, settings, or data from the cloud. The Windows 365 or Cloud PC is very useful for remote work, contractors, temporary employees, and secure access scenarios. One important benefit is that the data is stored in the cloud and not on the local device. So, even if the local device is lost or damaged, the sensitive company data is still protected inside the cloud PC that resides on the internet. Microsoft also handles software updates, security patches, backups, which reduces the IT workload managing the Windows 365 or the cloud PCs. The Windows 365 comes with its own set of advantages. It is accessible anywhere. Pick up exactly where you left off on any device with an internet connection, including laptops, tablets, and smartphones. It's easily scalable. Scale CPU, RAM, or storage on demand to meet changing business needs without physically buying any hardware. Simplified IT administration. Deploy and manage cloud PCs right alongside physical machines using Microsoft Intune. Enhanced data security. Sensitive data remains in the cloud rather than on local devices, minimizing risk during hardware theft or loss. This also simplifies the onboarding and offboarding process. Rapidly provision desktops for new hires or easily wipe access for contractors by simply assigning or revoking a license for Windows 365. Windows 365 also has predictable costs. The shift from massive upfront hardware investment to predictable subscription based per user pricing has made Windows 365 so popular. Thus, Windows 365 is a strong solution for cloud based desktop experience. Similar to the other services, the Windows 365 also comes with a few limitations. The first and the most important limitation is that Windows 365 or the cloud PC has a very strict internet dependency. Without a connection, no one can access the files, programs, or even the desktop. The latency issues can also arise. Few user indicates that video and audio performance is typically smooth if the ping times stays below 250 millisecond. Higher total cost. While it reduces the upfront hardware investment, renting a cloud PC long term is more than expensive than buying physical equipment or utilizing alternative service like Windows Virtual Desktop. Performance ceilings. They are not ideal for resource-heavy tasks like CAD, modeling, or 3D rendering, as cloud PCs max out at 16 virtual CPUs and 64 gigabyte of RAM. Microsoft also limits the outbound data transfer depending on the assigned RAM tier of the cloud PC. Exceeding these limits can result in restricted bandwidth unless you opt for a customizable enterprise plan with your own virtual network. Just in case if your computing needs outgrow your selected cloud PC plan, you might pay for a higher tier subscription rather than swapping out parts. With this, we come to the end of today's video. In the next session, we would start looking into how Intune tenant can be configured to make it ready for adding devices. If you find this video helpful, please like the video, share it with your friends and colleagues, and subscribe to Cloud Tech Services for more such technical videos. Also, comment below which topic you would want next: Windows Autopilot, Intune device enrollment, compliance policy, or Windows 365. Thank you for watching. See you in the next video.